Hey everyone, this is Subhatra Vijaykumar and I work with FPGA Workbench team. In this video, we'll briefly talk about PWM input IP module. The PWM input IP provides the ability to input a pulse pattern and measure the frequency and duty cycle of the input signal. Its functionalities include the following. It can capture pulse width modulated signals with high accuracy and capture the pulse counts. It's a debouncing digital filter. And the averaging window can be programmed via software. So the IP can be dragged and dropped in the FPGA Workbench GUI and connected to other blocks as desired. For this demo purpose, I'm connecting it to a DIO channel. We provide software development toolkit or SDK, which can be used to write your own custom application to communicate with the IP core on the board. This is one such C application that we wrote, which allows you to demonstrate the functionalities of the PWM IP core. These are all the configurable parameters that we support. When this program is executed, you can see that the channel 0 of the PWM input reads the signal from an external signal generator, which is 500 Hz and a duty cycle of 50%. Now, let me show a demo in which we can test PWM input using SimWorkbench. SimWorkbench has IP module configuration panel and IO mapping panel, which allows you to program the different parameters for your IP cores. So for the PWM input IP module, some of the static parameters are the debounce count, which is the filter count used in the debouncing circuit, average count, which is the depth of the FIFO, and dead limit, which is the number of clock cycles after a high or low, whereby the output will assume dead low or dead high. So these are the static parameters that you can configure for every channel. Similarly, the dynamic parameters for PWM input includes the frequency, duty cycle, and pulse count, which is read from the FPGA. So the test is already running. So when we go to real-time viewer, you can see the frequency and duty cycle of the signal that is input to the PWM input channel 0 via DIO channel 0. So it's of frequency 500 Hz and duty cycle of 50%. So if I change this frequency to say 1000 Hz in the signal generator, you will see it reflected here. So now the frequency is 1000 Hz. So this is how we test PWM input via SimWorkbench.